Hello everybody, welcome to our SQL Server Indexing Strategies tutorial. In this video, we will explore how different indexing techniques impact query performance by examining execution plans. You will learn about index seek, index scan, lookups, and covering index and composite index. Addressing this concept will help you write high performance SQL queries and optimize your database. Let's get started. What is an index? Okay, now what is an index? Index in SQL Server is like a table of content in a book. It helps SQL Server locate data quickly instead of scanning the entire table. Without indexes, the database must research every row, which is slow and inefficient. SQL Server has two main types of the indexes. Cluster indexes determine the physical order of row in a table and stores the actual data at the leaf level of the index. A table can have only one cluster index because data can't be physically ordered in only one way. And second is non-cluter index. Store only pointers to the actual data instead of reordering it physically. A table can have multiple non-cluter indexes. Improve performance for different queries. Okay, and we have two main ways SQL Server access to indexes data. First, index seek, and second, index scan. Index seek occurs when SQL Server effectively locate a specific row using the index's key values, typically with a high selectivity, like searching for a specific value using an equality predict. And index scan happen when SQL Server read the entire index or a large of a portion. Usually due to low selectivity, like retrieve most of the rows. Okay, first example of index scan. Okay, I create an orders table with a default cluster index. When you define a primary key in a table, SQL Server will create automatically cluster index, and a table can have just one cluster index. Okay, and in this step, I insert 100 records into orders table, and now I write a query in this table with the predict clause here. Okay, it's let me check it. Okay. Oh yeah. Okay, and I click here and jump in execution plan, and you can see here SQL query optimizer I used to this method index scan. Here you can see actual number of rows read is 100 records, but actual number of the row for all execution is 2. Okay, so cost is high, and I decide use a non-cluster index. Okay, for using index seek instead of the index scanning. I create a non-cluster index on a customer ID because here I use the predict here. Okay, and here I create it, and again run again query. Okay, return 2 records here. Oh yeah, okay. Here query optimizer use an index seek. Okay, what happened? In this execution plan, we see an index scan instead of the an index seek. This happens because the index only covers customer ID, but our query here, selects order date and total amount. SQL Server has to fetch these missing columns from this cluster index, which result in a key lookup or even of a full scan. Let's fix with the covering index. Okay, and what is the covering index? Covering index includes all columns needed for the query within the index itself. This prevents SQL Server from looking up additional data in the cluster index, eliminating extra I/O operation. Okay, here I write a TSQL code for creating non-cluster index and customer ID. Okay, customer ID include order date and total amount. Okay, and now you can see here use the index seek. Okay, and you can see actual number of rows read is 2, and actual number of rows for all execution is 2. It's same. Okay, now SQL Server can perform an index seek instead of the scan because all necessary columns, order ID, customer ID, order date, and total amount are part of the index. This reduces the workload and speed of query execution.